So this is the front panel out of my Altair 8800 emulator. I've got one with the full-size metal box that looks, very much like the original unit. And the intent here is to convert this into an actual S100 machine rather than an emulated machine. And part of doing that is going to be replacing the actual front panel electronics here with a front panel similar to the original one. And that's what this board set here will give me. So this board will replace the board that's currently in there that acts as an actual MSI 8800 front panel. And there's an S100 card here that then plugs into the S100 bus itself. That kind of completes the board set. On the original MSI, you use wire links from the front panel board over to the mother or the back plane, and it was just kind of an ugly, unreliable mess. These cards will provide the same functionality and get me onto an actual S100 machine. So kind of looking forward to this. It'll be neat to turn this from emulation into an actual S100 machine. So part of doing this involves tearing this entire front panel assembly down. Just really the first step, and I guess I should have looked for tools before I started yapping here. Oh, as always, the thing I need isn't here where I can see it. There it is. Hopefully I can break these loose. I've actually got a missing, that's too large, a missing socket in the extender for the ratchet. But for breaking these screws loose, this should work. I want to be somewhat careful doing this. I don't want to scar up that front panel. I just want to break these loose. Not super tight. They don't need to be super tight. And that should be hopefully enough that I can spin the nuts off. Why that one's being stubborn. It's going to be stubborn. So this isn't a system I've done a video. I've had this system long before I started shooting YouTube videos and played with it a bit. It's emulators are fun, but there's just something about actual hardware. It's more satisfying. And the last one here is going to be kind of a pain to get into. Oh, I've got nuts falling out of the tray somehow. Oh, come on, socket. A little bit fiddly. So that has dropped that piece off, and to keep the nuts and the spacers, I'm just gonna spin the nuts back on here. And this will get set aside for safekeeping, since I don't want burn it with a soldering pencil or scratch it or or any one of 100 nasty things that could happen to it. So there we are, all removed, and now to find a safe place on a shelf for this where it is well out of the way. Assuming I can find it on the shelf. That's a good spot. So next we move on to final disassembly here, and that involves spinning all the nuts here loose on all of these switches, which provides the mechanical support that holds the PC board in place. And then looking at the build instructions, we actually use this metal front panel to align the replacement switches and PCB into place for soldering. So we'll be getting into that here either in this video or in the next one, depending on how long this takes. You know, this is a nice little emulator. It does the job well. The idea of having an actual S100 machine in the box is much more appealing. You know, I've built a number of S100 machines over the years, you know, based on boards from S100 computers. But I've never had a case. I think I mentioned this in the CPU assembly video. I've never had an actual case that anything lived in. It's just been a stack of boards and a backplane on a table. So this should be quite nice. This is a rather spendy project if you were to have to buy all this standalone. I already have the case here. Like I said, I've had it for years. It's just been on display with my old machines. It'll be fun to breathe actual life into it. I have a huge collection of S100 cards, all the way back into the 70s, that I've collected over the years, and the majority of them work. And it should make getting something up and running here relatively simple. As we saw in the CPU assembly video, I will be using a reproduction CPU initially in this. Now the board's finally coming loose, starting to drop off screws and washers, and I should be able to lower the board hopefully out of here. I guess I'll just tilt this forward and pour all the hardware off of it. Collect up all the hardware, get it into a storage bin. So there's the emulation system. There's obviously a processor over here, some surface mount logic. You know, see, this is a good little emulator. It's from FarmTech Incorporated, copyright 2013. I don't know if this is even still in production. Board's from 2013, so I've had this thing potentially 6 years. So like I say, it'll be really fun to replace this card with this card and turn this into an actual machine. So again, this needs to be set aside and kept in good shape. It may get reused in something at some point. Probably should have put all the nuts and washers back on the switches, but I didn't. So let me set this aside as well. I know we need this. And the PCB, and I've got the assembly instructions here. And we'll begin looking at what it takes to bring this together. So I actually bought the APM switches for it. So really first thing they want is to get all of the components in place. So really this can all be set aside for now. Oh, doggone it. And we can really move on to components that actually go on the board here. So R1 to 36, I need 2K and 4.3K ohm resistors. It looks like 2K and 4.3K. R1 to R52. Let me go pull resistors. I may not have enough 2K ohm resistors. R1, so 2K ohm are 36 of them. I seriously doubt there's 36 2K ohm resistors there. There's almost no way there is. I didn't order resistors when I ordered other parts. So I'm going to make an executive decision here, and I'm going to use 2.2Ks since I have plenty of those. That should be plenty. Should be close enough. Of course, it might be something I regret and have to go back and unsolder everything. So these are, let's see, that is R1 to 36. So these are the current limiting for the LED. So this will make them a little bit dimmer. He calls for 5%, which is pretty standard. So, you know, 5% would be, I'm still kind of outside of 5%. If I go with 180 ohm or 1.8K, they're going to be brighter. I think I can live with the 2.2K for current limiting, and those are really R1 to R36. Make sure these are all 2K2. Looks like red, orange. Or red. It should be red. So of course the quick test here, or the quick test is just to measure one in each strip, make sure they're what I think they are. Get into ohms here. .15K, 2.16K, 2.17K. Must have lost contact on it. And 2.2. So these are really closer. 5, 10, 15, 20. There must be 30 in this strip. So I'll need to think about this. I'll probably use 16 of these down here for the address bus, and then these set of these up in the data and status indicators. So really now it just really becomes a matter of stuffing resistors. Ah, there's excited doggies outside. I don't know if I've got a lead forming. It'll go tight enough for those. That might. That one certainly doesn't go small enough. That one doesn't go small enough. 0.4 might work. We'll have to bend one and see what we get. So for now I'm just going to clip one out. Give it a bend and see if it'll drop in. And it does. That's perfect. So I'm going to want to bend these at 0.4. It looks like they're all the same. So I will sit here and clip out all these resistors and get them bent and in. Just finished soldering in the second bank of resistors. That gets me R1 to R36, which are the current limiting resistors for the LEDs. I missed a solder joint. I substituted 2.2K for the 2K he called for. Oh my god, I missed a bunch of solder joints. Which means my LEDs will be a little bit dimmer. Have I missed any others along there? I must be really distracted today. I got those sockets in upside down in that earlier build. I'm missing solder joints. Maybe it's not a good day for kit building. That's always a good day for kit building. So like I said, my substitution of a little bit higher resistance resistor is just going to mean the LEDs won't be quite as bright. For me personally, LEDs are too bright in almost everything. Well, those aren't steel leads, so I can't pick them up with the magnet. Gets those resistors in place, and then we move on to the 4.3K. And as far as I can tell, looking at these, they're pull-up resistors for the switches. I don't really understand why such a specific and non-standard value. It's just kind of a mystery to me. Manual here again. So R37 to 52, 0.43K, quarter watt, 5%. Specify the LEDs provide appropriate brightness with the 2 kΩ resistors. You may need to choose a different resistor value if different LED is used. That's fine. Really, I mean, those 4.3K are pull-ups. And 4.7 just for pull-ups just doesn't seem like it's going to make, honestly, that big a difference. It'll pull up slightly slower, I'll put it that way. Those are 2Ks, that was the 2.2s. So I have plenty of 4.7s. I need 4, 8, 12, 16 total, I believe. Of course, I keep closing the assembly instructions here. Yeah, so I need 16. This is going to be the same exercise again, so I'm not going to bore you by taking you through the whole process. But cut out resistors, form the leads, insert the resistors, solder the leads, etc. So I'll come back when we have those resistors in.